Wildlife photography can be very challenging, even by just shooting at your backyard. This week, we're building a motion-triggered DSLR remote control. It's an Arduino-based wireless system that triggers your DSLR when a separate circuit called a beacon detects motion. When it does, it transmits a wireless signal to the receiver. The receiver then tells the DSLR to click the shutter button repeatedly from afar. As a result, you'll be able to get photos when you're not around. In my case, I caught a photo of this bird scavenging food from the dumpster. By repositioning the beacon in a camera, I was able to get another photo from a different angle. It works on trees too. Here are the things you'll need. In this project, you'll need 2 Arduino Uno boards with cables, a pair of power banks for the Arduino's power supply, a set of prototyping boards, a supply of jumper cables, a dollar store motion detecting alarm, an IR LED which you can recycle from old remote controls, and finally, the most difficult to get, a TX-RX serial communication module. I got mine from a local hobby store. If you want to buy the cheaper version online, go visit Deal Extreme and buy it for around $2.60. By the way, free shipping is included. First, let's build the receiver device. Grab your Arduino Uno, your prototyping board, and your receiver module. Start by pushing the pins of your receiver module to your breadboard. After doing so, you'll need to know which wire goes to which pin. You can find out by visiting the manufacturer's website. Since I bought my serial module from a local store named Alexan, I searched for it from their website. This drawing shows the pin layout of the receiver module. You will only need to locate 3 main pins. The first pin would be the digital output. Connect the receiver's digital output to the Arduino's 12th digital pin. The next pin would be the ground. Share your receiver's ground to your Arduino's ground. The third pin would be the VCC. The VCC goes to your Arduino's 5-volt pin. Remember when I mentioned that the receiver sends wireless signals to the camera? Well, that signal is IR. That is what the IR LED is for. Insert the LED's negative pin to the negative jumper's rail and the positive pin to the other side of the breadboard. Next, connect a 470 ohm resistor to the LED's positive pin and a jumper at the other end going to the Arduino's 11th digital pin. You're finally done with the receiver circuit. Set it aside for now because we are going to work on the beacon circuit. The beacon works as a wireless motion-activated unit. It's basically made of a motion-activated alarm. Since PIR modules are quite expensive, I decided to buy a cheaper alternative. It's a dollar store door chime. It's not compatible with Arduino just yet. It requires a simple hack that would make it work with an Arduino. The hack is done by tapping to the wires of the speaker. But first, you will need to drill a hole for the wires to come through. Find a good hookup wire, then insert it through the hole that you have just drilled. The alarm makes a very loud sound that could startle the subject. So, I unsoldered the wires, then soldered it directly to the hookup wires, disabling the speaker from making a sound. I used heat shrink tubings to insulate the wires, preventing it from shorting. Once done, put the alarm back together. Trim and snip the hookup wire. Then tin it with solder. Insert a 2-pin male header on your breadboard, then solder the hookup wire on each pin. Grab your prototyping board, then insert the transmitter module to it. Go back and visit the manufacturer's website. Then search for the transmitter's pin map. Just like the receiver, the transmitter has 3 main pins. The first pin would be the ground. Connect a jumper from the transmitter's ground to the Arduino's ground. The second pin would be the VCC. Connect a jumper from the transmitter's VCC to the Arduino's 5-volt pin. And the third pin is the data input. Connect a jumper from the transmitter's data input going to the Arduino's 12th digital pin. I forgot to mention that the transmitter has an additional antenna output. If you want to get an extra range, you can make one. So far, I'm fine without an antenna. Grab your modified motion sensing alarm, then insert the male header to the prototyping board. If you recall, that wire is an extension of the speaker. For the Arduino to receive a signal from the alarm, connect the speaker's ground to the Arduino's ground. Then connect another jumper from the speaker's positive output to the Arduino's 0th analog pin. Then install the batteries of your alarm. the output should look like this. Here's a tip. If you want to make this more permanent, buy a plastic enclosure for housing your components. You're one step ahead from finishing the project, and all you need to do is to program the Arduino. Below this video, I provided a downloadable link. It's a zip file, so you'll have to extract it on your desktop. You'll find two folders, one for the Arduino codes and the other for the additional libraries. Click on the library folder, then open the properties window of your Arduino program. Next, click the open file location. In order for the codes to work, you will need to install the additional libraries to the Arduino's IDE. You can do so by copying the additional libraries I gave to the library folder of your Arduino program. When you're done, you can program. Start with the Arduino unit of the beacon. You can find the codes for it by going to the transmitter folder. Then open the transmitter Arduino code. These codes are ready to use. Just select your Arduino board's model. Then select the COM port where it's connected. Just click the upload button and the sketch should upload to the board. Now you're done with the beacon unit. This time, we are going to program the receiver. Go to the receiver folder. You'll find 6 folders. Select the one that's compatible with your camera brand. Then open the sketch. Do the same thing again, but this time on the receiver unit. The Arduino needs a power source. USB power banks serve as an ideal power source for Arduinos. Turn on your camera because we need to optimize this for our setup. If you are an Nikon user, follow me. Click on the quick setting button. Select your focus mode to AFF. Now go to the AF area mode. If you're planning to track humans, select the phase priority. There's also an object tracking mode. Finally, in order for the receiver to communicate with the camera, you'll need to set the camera to the remote control mode. Set up your camera far from the area where your subject is most likely to pass by. In this setup, I'm using a Nikkor 80-200 f2.8 fx lens. Instead of using a full-frame camera body, I decided to use my crop sensor camera together with a full-frame lens. When a full-frame lens is mounted on a crop sensor, the minimum and maximum focal length will be multiplied by 1.5 respectively. I'll show you what I mean. A photo taken by a full-frame camera with a full-frame lens looks like this. But if you replace the full-frame camera with an APS-C camera, there will be an increase of focal length by 1.5 times. It should give us enough boost to get a closer shot of the subject. Let's go back to the Arduino. Keep the receiver unit close to the camera and set up the beacon within a 200-meter range. When you're not around, it will automatically take photos for your convenience. So sit back and relax. And that is how you make a motion-activated DSLR remote trigger. Have fun and stay tuned because there's more to come. Thank you! If you have questions or inquiries, visit me at instructables.com.